Okay, here's a series of topics that we can use as a review for the reaction rates unit. You could also call it a frequently asked questions. Some of these questions we'll answer, and some of them we will not. You can just use this to study on the printed sheet, or you can listen to this screencast and pause and try to answer the questions on your own. Notice that some of these questions I am not providing answers for, so you should just write them on your own. What's the rate of a reaction? Well, that's the change in concentration over time for a reaction or product. Does each chemical reaction have a reaction rate? Not as a single number, because it's going to vary with temperature, surface area, concentration, the presence of catalysts, and can vary for each reactant or product, where the stoichiometric coefficients can help you a little there. What is the initial rate of a chemical reaction, and how can it be measured? Well, that's the tangent of that initial slope that relates concentration and time, where it's tangential at t equals 0. What's the average rate of a chemical reaction? Well, it depends on what you're looking at, but it's the rate of a reaction over a period of time with respect to any reactant or product that you're interested in. Any nonlinear variation within that time frame would be missed, as it would be any time you take an average. If things are a curve, it's not going to know that it was curved. What's the instantaneous rate of a reaction? That's the rate of reaction at a given point in time. It could be time equals 0. It's equal to the tangent of the curve at that point in time. And if that sounds weird, go back to the screencast, and there's some nice images there that should help you. Oh, this is already answered. Rate is about concentration. Rate law is about concentration versus rate, and integrated rate law is about concentration versus time. Tell me everything you can about rate constants. What is a rate constant? That value K, right? It's a measure of how frequently a product is formed or reactant reacts. That makes sense. What are the units? Well, it depends on what order you're talking about. 0th is molar versus time, so molar per second. First is 1 over time. Second is 1 over molar times time. And third is 1 over molar squared times time. And you could extrapolate from there. That's a good thing to know, but it's a hard thing to remember long term. Tell me about plotting them. Well, a 0th order reaction is going to be linear for concentration versus time. A first one is linear for the natural log of concentration versus time, and the second order reactions are linear for 1 over concentration versus time. That shows up on just about every AP exam. Do they change with temperature? You betcha. And so they usually give you a temperature at which the reaction was performed because they really need to, but you can ignore it typically at that point. Is there anything else we should know? Well, we'll be dealing with lots of K's, and we'll compare them for each unit. Notice that the rate K is expressed in relation to reactants only. So as we go into equilibrium, there'll be an equilibrium constant. There's lots of other constants that are going to show up throughout the school year, and it's nice to try to keep them straight. Notice that in this case, K has nothing to do with the reaction coefficients. There'll be some minor exceptions dealing with reaction mechanisms, but in general, K has nothing to do with the reaction coefficients. And here it is, except for its use in mechanistic steps, where in those cases, the coefficients are the exponents in the rate law. That only shows up for those when they give you the mechanism. Typically, it's important to know that K is determined experimentally. Here's some questions you can answer on your own. Tell me integrated rate law formulas if you can remember them. Have a look at that green sheet and you'll see that there's not much there, so you do have to know those. Tell me about half-life, definitely for first order, and if you know for 0th order and second order, and what it means. Here's another couple of questions on your own that you can write in. Tell me a little bit about the Arrhenius equation and how it plots. Also tell me about what exactly do we need to know for AP chemistry about the Arrhenius equation. New sort of, show a reaction coordinate and what you can say about it. Here's some other little ones. Tell me about reaction mechanisms. Which is the step that really matters? What can you do with it? How can you identify catalysts and intermediates? Can you use the reaction mechanism to determine rate order? I think, did I just ask that? How can you determine the overall chemical reaction? Okay, so I added one to it. Those are some nice things about mechanisms. Okay, we're up to the problem set now. This completes the videotape parts for rates of reaction.